Hello. So I hope everybody's fine. So like my name is Nikola Milosevic. I am part of Bayer R&D in Department Data Science and AI. And like I'd like to introduce today the Dify plugin that we have made in a bit of like collaboration with Neo4j. So like with Michael Hunger. Like I'll basically start in case you don't know what is Dify. So it's an open source product for building AI workflows, and basically on the right hand side you can see like how it looks like. So like you can have this kind of like nodes, and you can connect them and basically build your workflows. And these nodes could be anything from LLM to kind of like full-blown agents that are like working in some kind of like React manner. So kind of like have this like a reflect and act kind of like architecture. Those nodes could be as well kind of like integrations with a bunch of other tools, including like Elastic Search, vector stores, some like number of memory engines, other kind of like search engines, data, like data, different kinds of databases, and so on. And as well, there could be kind of like branching and so on. So it's pretty powerful tool. It is like there are a number of tools on the market right now that could do similar things, such as like N88 or I don't know, like Pipeline Pilot 9 or so, that are kind of like more traditional and like not really built as kind of like agent first or AI first engine, but like more kind of like for automation, where if you like stands out, it is a little bit more on this kind of like LLM first, and it builds for you like the whole kind of like chat interfaces. You can share it with users and so on. So it can, like once you build the pipeline, you can expose the workflow as either UI, so it can build either a form or a chat, but you can as well expose it as API or like MCP server. So it's like pretty powerful tool that lets you easy and quick prototype agents or kind of like AI workflows that are utilizing large language models or not so large language models. It has integration with all kind of like cloud providers that are hosting the LLMs, and as well like you can self-host them and so on. So yeah, like all in all, pretty powerful tool. However, like they have a marketplace with all sorts of like plugins. As you can see on the right side, so there are like integrations with like a number of models, tools, agent strategies, extensions, bundles. There are like around like hundreds of plugins, or at the time when we as well like started looking into the Dify as a tool, it basically already had kind of like hundreds of plugins. However, like what was missing was basically a Neo4j. We basically had the pipeline in mind that like I will show and explain in the next slide, that shows basically what was the use case that we were trying to address. And then like we found out that it's pretty easy to implement as well, like your own plugin. So like it is based on Python. You can code like basically a single Python file that does all the kind of like handling with of the data and so on. And there is a YAML file that defines certain things like parameters and some kind of like this descriptions. These plugins can be easily published to the marketplace via GitHub repo. So basically you can, we found out that you can basically make a pull request to the official GitHub repo that hosts all the plugins that are published on the marketplace. Once the pull request gets approved, it's automatically there on the marketplace. So yeah, like as I said, there was missing Neo4j plugin, and then we decided just kind of like to build it ourselves. And yeah, like the use case that we had a bit, I don't know, like 2 years almost ago, was that like we started building a knowledge graph that integrated the data from a number of different data sources, such as that time there was a UK biobank, like some data we needed to delete from the UK biobank because of like some regulatory reason. But there was kind of like integration with like String, with Campbell, with various like public knowledge graphs like PrimeKG and so on. There's like drug bank, GTEx. We had some kind of like internal sources, so like we had internal literature and so on, and internal like single cell studies, UniProt, and so on. So like based on this knowledge graph that we had, we wanted to create a pipeline for the target identification. So like basically to find a gene that we can target in order to treat a certain disease, in case you are not from the life sciences. And the pipeline that we try to do is basically that we look at the cell types, then like we queried language models asking it to filter to the cell types that are relevant for the given disease. And then we would query again like a knowledge graph to get genes in those like cell types that are either marker gene and that are either under or overexpressed. And then there was kind of like initial run of like LLM classifying these genes, whether they should be included in further analysis or they're kind of like irrelevant, or the LLM can be as well like unsure. And then we would pull more data from the knowledge graph. So this could be things like whether there is a direct gene disease link, whether there is indirect link. So like I believe like we looked at up to like 3 hops. Are there like mRNA that regulates this gene positively or negatively? What pathways this gene is part of? What are kind of like the functions of this gene? Are there like any protein-protein interactions? And we looked as well like on running clinical trials. And this as well kind of like mapped into the scores that we wanted to give to this like method. So basically then all this data were like passed to LLM, which was supposed, there was like some kind of like chain of thought prompt asking to rank on a score of like 1 to 10, like how strong disease link is, how good is like safety of the this like gene, is it druggable, or like how good is druggability. Based on kind of like clinical trials, you can as well kind of like explore how fierce the competition is. So like who is running clinical trials in this similar gene, and then there was some sort of like average. And then kind of like the next step was kind of like to try to establish a link with patient population. So there was basically a lot of kind of like querying and then going back to the knowledge graph and to the LLM. And then like kind of like if you extrapolate it, what would be the further needs of like having Neo4j plugins? So like basically there's a lot of need of kind of like grounding information. So you want the LLM to not hallucinate, to base the responses on something. So like whether it's literature or something like structured. So in a structured sense, for us, the integration was done on Neo4j. And as well, kind of like for that, you could do kind of like a graph rag. You can verify the answer, whether it is really kind of like based on something. So we had as well like a project with Fraunhofer Institute where we looked at kind of like verifying the responses from LLMs with kind of like knowledge graphs that were kind of like underlying and that were queried. And then as well, kind of like data source expansions, and it could be used as kind of like agentic tool. So yeah, like basically we built this Neo4j query tool, and as well like open sourced it. So like you can find it in Dify marketplace and just use it. And there is as well kind of like a GitHub and so on associated with it. Like there will be links later. So basically, it allows authentication to your Neo4j database, whether it's local, remote, deployment, Aura, cloud, anything kind of like would work. So you can just kind of like connect, and then basically you can add queries, and those can be parameterized. You can kind of like query across different databases. And as well, these kind of like parameters could come as output from some other node in the pipeline, whether it is LLM or it is some kind of like code node. So like Diffie allows as well a code node, or it could be like coming from some other systems. And like what we thought is as well kind of like important is to have the switch for allowing write queries. So it is by default on false. So like if ever there is a query that comes from the previous nodes that wants to write into your knowledge graph, it would not allow it unless you consciously allow it in the configuration of this like Diffie tool. So this would kind of like prevent that, like basically LLM does wild things to your knowledge graph and may changes the integrity of your data and so on. So yeah, like basic, and it's as well kind of like this is done in a way that the query has this kind of like pre-flight mode, and then like based on that, it kind of like flags whether it is writing query or not. So like before execution, we know that we won't accept the query to execute. Like basically here is some kind of like simple workflow or like sample of like what you can do. Here what we did is basically we have a start node that like user inputs whatever question, and then basically we connected to Neo4j database where we called this like DB schema visualization, which would give us the schema of our Neo4j database. And then there will be a LLM that we would pass the result of this query, so like to which we would pass the schema. And with the schema, we would as well like prompt this LLM, which is in this case like Gemini. And Gemini was here used because of the quite long context size. So even if we had like quite large graph, it would still kind of like fit, or large schema of the graph, it would still kind of like fit into the model context. And then it was prompted basically to generate the Cypher query that would try to answer the user's question in in the next node, we would kind of like call Neo4j with this query. And in the last one, we would just kind of like try to verbalize what came out of the query. And there is like some use case that we as well like try to do with this like clinical knowledge graph that is like open source, and we try to describe it. So here you have like a number of like relationships centering around like clinical findings around like some patients and their kind of like tissues, proteins, interactions, and so on. Like there are as well like some challenges that we figure out that like it's worth mentioning, especially if you're working with like large language models and knowledge graphs, that LLMs could struggle to like query your database in the right way, but then kind of like you can do some things to make it better. Like basically prompts can be filled with parameters from other nodes, so like user questions, graph schema, and so on. So this is basically how our prompt for this like clinical knowledge graph look like. So we said that based on the user question and the Neo4j knowledge graph schema, and then like you pass the schema, write the Cypher query that would fetch the data from the knowledge graph, helping to answer a question, make sure to capitalize the first letter of each word, and blah, blah, blah. This as well kind of like requires you to know basically how the data is, or how the nodes or the relationships are represented in your knowledge graphs. So you need some kind of like description that like, well, is it starting with a capital letter or so? And then somehow to know how the things are phrased there. And so basically this kind of like naming convention that you are using are important, and it can be a little bit a challenge to describe. And I see that somebody is writing in a chat like, don't you use ontology to unify the terms? Like one way to do that is to normalize to some sort of like IDs or some ontology, either like UMLS, Mondo, or something like that. And then basically use either ID or preferred term to kind of like do that. But this would kind of like require you to add additional step. So here I can kind of like, here I'm showing like this querying ontologies with, so we have built internally this like linears tool, or I mean, we didn't really build it from scratch, but there is already open source tool linears. We modified it a bit and then kind of like included our dictionaries of synonyms, and then kind of like normalize it to some our internal ontologies or ontologies that we are using. And that node is basically doing for us this kind of like entity linking to the particular IDs or to the given ontologies. And then you can kind of like pass the schema, pass these kind of like IDs, and then like based on these IDs, generate the Cypher query that would be kind of like more reliable and kind of like better to use or easier to use. And like basically the end result is like you can ask the questions, what proteins are part of mitopic propase pathway, and it would answer like based on provided data, the following proteins are part of this pathway, and then kind of like list things. And this is as well like how the interface, like chat interface within Dify looks like. So it will generate this UI for you. Like basically for conclusion, so like we are introducing here this like Dify plugin that's for basically easy building and grounding either agentic or LLM workflows. So like you can use it as well as a tool within Dify agent node, and as well like you can use it as kind of like a separate node. And it could be, like basically, as I said, like used as a part of the pipeline or as a tool in the agent. And with this like retrieval and reasoning over the schema, you can generate a Cypher for querying Neo4j database. But then like I would recommend using some kind of like ontology and entity linking and normalizing your terms. Otherwise, you may have quite a bit of troubles. And it can kind of like execute both retrieval and write queries. And it is open source and available for Dify, so it already has over 2,000 downloads, and like people are, it seems, using it quite happily and successfully. So basically, once you have like deployed Dify, it is basically one click to install it in your environment and provide it to your users. So it's very easy to install and set it up. There is this kind of like link to Marketplace and then GitHub, and basically it was mostly written by myself, and then like there was a bunch of ideas coming from Michael Hunger about like what we could include and what we should do, which was at some point implemented for the most part. But like we are still kind of like looking for ideas and stuff to improve. So like in case you have idea, feel free to raise an issue in GitHub repository. It's more than welcome, and we will try to find the time to implement those things. And like basically that's it from my presentation, and like we can go for some questions if there are any. Like I saw in chat quite a few, but should somebody go through it, or like Brenly, or so? How do we prioritize or so?
Yeah, we can. It looks like most of them, Nikola, ended up in the chat, not in the Q&A. So if you want, you could either stop sharing, and then it might make it easier to see those chat messages. And if you like, most of the questions are towards the end. So you might be able to. There were some early ones just wondering, how Dify was different from another system like Flowise, and then people wondering about how to integrate with your enterprise system, and then some more. So basically, if you scroll back to about 1:30 or 30 after the hour, then you'll see a lot of the questions starting.
Yeah. Okay, so like I can read them and then like just try to respond. So is Dify integrated with your enterprise system? So like we have a deployment in like one of our systems, and we have, I don't know, like 100-ish users. And we have connection to like Neo4j database that I presented as kind of like integration of like many of things. Although that is now a little bit changing the structure, so there are like some things that need to be redone. But it is connected to a few enterprise systems within Bayer. How does it differ from Flowise? I don't know exactly Flowise. But like there, as I said, like there are a number of these tools. Like when I was looking at them, I needed something that's kind of like easy to deploy, easy to play with, that doesn't need too much overhead with like licensing and so on, and that I can kind of like roll out and collaborate with people. So kind of like Dify had most of those characteristics at that time, provide a little bit better, at least like for my use case functionality than N8N8, like that I looked at kind of like a comparison. But yeah, like as I said, on the market there are a number of those tools. So like there's N8N, there's probably this Flowwise, there's Nime, now supporting LLMs and agents, and so on and so forth. So yeah, like this is one of the systems that you can do such things. Like there is quite a bit of competitions. So is AlphaFold integrated with your system? So not with this one that I described, but we are building some sort of like co-scientist, kind of like multi-agent platform that has already like AlphaFold integration and as well like some of the kind of like multi-omics pipelines. This basically, like when it comes to multi-omics, it basically pulls the data from this like database and some literature. Some of these data are like genomics, some are proteomics, some are so there is a bit of like more than one omics data, but like mostly it is about like relationships and so on. There is no really raw data there. So yeah, like basically the way at the moment is that it just kind of like pulls the data and passes it to LLM to analyze. And there is not much of kind of like yeah, like calculating anything from raw omics screens or data. But that as well kind of like would be part of this like co-scientist platform. This save everything about text-to-cipher tool executions. I'm not completely understanding these questions, but yeah, like what I describe is a bit of a text-to-cipher, or like how do you build this text-to-cipher? And there is this question about ontology to unified terms. Do you have a dedicated entity linking node before the step to map user terms to Mondo ID, or do you rely on LLMs to perform the translation on the fly within the prompt? So like we do have entity linking. As I said, there is this kind of like Linnaeus tool, which is as well kind of like a little bit modified and integrated with our dictionaries open source tool. But that we didn't open source because of like some reasons. In a large scale R&D databases, the schema is often too big for a prompt. Do you see a subgraph schema extraction technique to only show the AI relevant node for a specific question? So yes, this is a good point. And we did that quite a bit. So like, even if you pass LLM the full schema, and like the models such as Gemini 3 or Gemini 3.1, like they have like 1 million token context, they can swallow this schema. However, they quite often would make mistakes, at least in kind of like directionality of the nodes in the Cypher query. So therefore, yeah, they are as well like much more comfortable using like smaller kind of like subgraph nodes. Do you find that few-shots example were necessary to maintain the script normalization rules you mentioned? I mean, it helped, but I think like mostly it was like about like passing the schema and trying to kind of like isolate subgraph that is relevant for the question. And for that, then kind of like you can't really know which part of the graph you would use, and therefore kind of like providing the cipher for that part of the graph would not be possible. And that's, I believe, it. And we are at time, right?
Yeah, thank you so much. That was great. And thanks for all the participation from everybody and the questions that you're able to answer. Incredible. Thank you.
Thank you.